Dana's lesson. So, kamusta kayo? May natutunan ba kayo ng ating mga previous lessons? This time, still we are going to talk about topics on physical science. Again, this will be another fun learning experiences to all because we're going to deal with the abiotic factors in our environment, such as the occurrence of light and some other phenomena that we are experiencing in our physical world. So let's not prolong the agony, let's explore them. So our topic for today is all about the wave property of an electron. So, in this lesson, you will be able to cite some experimental evidences showing that an electron can behave like a wave. So last time, pinag-usapan natin na ang photons or the particles of light or light itself can behave as a wave and also as a particle, diba? So in this topic, we're going to deal with electrons. So in the last lesson or in the preceding lesson, you learned that light can behave as a particle and as a wave, right? So the idea of photoelectric effects, which shows that particle property of light, fascinated the French physicist Louis de Broglie. If light being a wave can show a particle-like property, then electron and other particles may also have wave-like properties such as the wavelength and frequency. Sabi niya, kung ang light daw ay merong particle-like property, maybe daw electrons or some other subatomic particles, the neutron and the proton, may also have properties such as wavelength and frequency. Yun ang gustong patunayan ni Louis de Broglie. But before that, let's have first a bit of history. Tingnan natin kung paano nagkaroon ng evolution ang idea na mayroong property ang electrons. So in 1990, Max Planck was able to formulate and discover the so-called Planck constant. Naalala niyo pa kung ano ang value nun? 6.63 times 10 raised to 24 joules, which included in his discovery of the Planck's radiation law. So after that, in 1905, German physicist Albert Einstein, kilalang-kilala niyo siya, diba? First showed that light, being considered as a form of electromagnetic wave, can be thought as a particle and localized in packets of discrete energy. This was shown in his photoelectric effect. So after Albert Einstein, the observations of the Compton effect in 1922 by American physicist Arthur Holly Compton can be explained only if the light had a wave-particle duality. So yung kanyang postulate ni Compton ay may explain lang kung ang light daw ay mayroong particle and wave property. As you remember, diba last time, the wave and the particle property of light was dependent on the phenomena that being observed. So it means hindi lahat ng phenomena na nakikita natin can be explained that light can behave as a particle and can be explained that light can behave as a wave, diba? Now, fascinated with the idea that light as a wave can behave a particle-like property, in 1924, French physicist Louis de Broglie proposed that electrons and other discrete bits of matter, maybe the proton and neutron, which until then has been conceived only as a material particles, must also have a wave property such as wavelength and frequency. So itong ating mga scientists noon ay nagkaroon ng kanilang mga studies about the property of electrons and the light, of course. Later, in 1927, the wave nature of electrons was experimentally established. Ibig sabihin, hindi lang postulate, hindi lang haka-haka. Nagkaroon talaga ng experimentation by American physicists Clinton Davison and Lester Germer on their Davison-Germer experiment. An understanding of the complementary relationship between the wave aspects and the particle aspects of the same phenomenon was announced by Danish physicist Niels Bohr in 1928. So that is the history behind the idea that electron has a wave property and also a particle property. So let's move on. Ano nga ba ito? Electron being considered as a wave created questions that gained the interest of many other scientists. So, dahil sabi nila, nagkaroon ng idea na ang electron, maliban sa light, ay mayroong wave and particle property. Nagkaroon ng maraming mga haka-haka at mga tanong tungkol sa idea na ito. Among the questions that lingered on their minds of these other scientists was that, if electron traveled as a wave, then where could be the precise position of the electron within the wave? Ang kanilang tanong, saan mismo ang precise position? Saan natin matatagpuan ang electron within the wave? Kung pinopropose nyo na merong property itong electron, saan siya makikita within the wave? Yan ang katanungan ng other scientists kasi gusto nilang malaman. Grabe no, gayon sila ka-curious. Hindi sila nagsisettle down lang sa basta kung ano ang present ng other scientists, kung ano ang meron na. So they are asking for more. Sinabi niyong ganito, so saan niyo makikita? Grabe talaga ang kanilang curiosity. Kung kaya ngayon maliliw na sa atin, kung ano ang alam natin ngayon, it is because of their curiosity. So ganoon sila katalino. So ayun na nga, na-post na ang kanilang tanong, kung saan ang precise position ng electron. The answer to this question was given by German physicist Werner Heisenberg in 1927. In his famous Heisenberg uncertainty principle, he articulated that both the momentum and position of the electron cannot be measured exactly at the same time. Sabi niya, imposibleng ma-measure natin ang exact position ng electron within the wave. Yun ang sagot ni Werner Heisenberg. Another scientist in the name of Erwin Schrödinger derived a set of equations, also called the wave functions, for electrons as a result of de Broglie's hypothesis and Heisenberg's uncertainty principle. So itong scientist na ito ay nag-base sa mga postulate at sa idea ng dalawang scientists. He formulated the equations that would specify that the electrons confined in their orbits would set up standing wave, and the probability of finding electrons in the orbitals can be described as the electron density clouds. He proposed na maybe ang probability na makita natin ang electron ay sa kanyang orbits. He said that the greatest probability of finding an electron in an orbital is in the densest area. Mas makita daw, mas malaki ang probability na makita natin ang electron sa mabigat na area. Likewise, the lowest possibility of finding an electron is in the orbital of the least dense. So, mas mababa ang probability na makita natin ang electron sa magaan na area. Ang mas may malaking area na makita natin ang electron ay sa mabigat. That was the idea of Schrödinger. That was the history behind how electrons considered as a wave and a particle property. Now let's move on to another lesson, which is all about the properties of light. As you may recall, the wave-particle nature of light can be explained why light is reflected, or it may bounce back as it hits an opaque surface, or it shall be refracted or bent as it passes through a transparent material. So, what we're going to know in this lesson is that you will encounter more properties of light that may uncover the formation of rainbows. So, paano nga ba nagkakaroon ng rainbows? The rainbow-colored soap that you played with your younger siblings, siguro naman nung bata kayo, kahit ngayon, di ba? Ginagawa nyo pa yon. And also the beautiful horizon that you experience in the late afternoon and the white fluffy clouds below the blue sky during the midway. So kung titingnan natin, napaka-common lang ng mga phenomena na ito. Pero ang tanong, alam nyo ba ang science behind it? So we're going to explore it in this lesson. So come along. The first subtopic that we're going to explore is all about dispersion and scattering of light. As light enters into a prism, nakita na kayo ng prism, di ba? So, if we're going to put it directly in the sun, makikita talaga natin yung rainbow, di ba? Or any object that may act as a prism, it separates into different band of colors, the rainbow. The separation of white light into these different colors as it passes through a prism is called dispersion. The separated band of colors, the red, the orange, the yellow, green, blue, indigo, and violet ranges from 400 nanometers to 700 nanometers in wavelength. Dispersion occurs due to the slight difference in the refracted index of each color. Alamin natin kung paano ito. So, rainbow. Diba? Napakagandang tingnan tong rainbow. Kasi according to the Bible, this is the sign of the promise of God, diba? Na hindi na niya gugunawin ang mundo ulit. But according to science, rainbow is formed after a rain shower when droplets of water, mga drops of water in the sky act as a prism. Yun pala ang nag-act as a prism in the sky, the water droplets that separate the rays of the sun hitting the water droplets into a band of different colors. So once the rays of the sun hits those droplets of water, it separates into different colors and we can see the currents of the rainbow. Another one, scattering of light is responsible for this blue-colored sky and the beautiful horizon. Ang responsable kung bakit nakakakita tayo ng ganung mga phenomena o nakita natin na blue ang sky at the other red, orange, or color orange during sunset. Tiny dust particles and other atoms of oxygen and nitrogen in the atmosphere, which are far apart from each other, act as a scatterer. So kung meron tayong nag-act as a prism, meron din tayong nag-act as a scatterer kung bakit nakikita natin na ang sky is blue and the red-orange horizon during sunset. So this is scatterer, the tiny dust, the atoms of oxygen and nitrogen, scatter sunlight in all directions. Of the band of colors of light, violet has the shortest wavelength of 400 nanometers and it is scattered the most, followed by indigo, blue, green, yellow, orange, and red, which has the longest wavelength and scattered the least. So kung ganun, kung ang mas nakascatter ay kulay indigo or kulay violet, bakit nakikita natin ay blue? It is because our eyes are not sensitive to indigo and violet. Ang mas nakita ng mata natin ay kulay blue. And it is the most predominant to our sight. So, we see the blue sky. So that's the science behind it. Next would be, in the late afternoon, where the sun is on the horizon, the longer wavelength, anong kulay ang longer wavelength? Red. Reaches our eyes more than the blue light and other colors, which scatter the most. Red, being scattered the least, is transmitted and passed through more of the atmosphere than any other color. Kaya ganun ang kulay na nakikita natin during sunset. And it is very beautiful, di ba? Napakaganda. There are many people who adore sunset very much. Kasi totoo naman talaga na napakaganda ng sunset. Thus, it is the red color together with some orange. Minsan may nakikita tayong orange that reaches our eyes in the late afternoon and we see the beautiful red-orange sunset. Thus, it is the red color together with some orange that reaches our eyes in the late afternoon and we see the beautiful red-orange sunset. Parang ganito, di ba? See? Napakaganda niya. Now, let's know the science behind those white clouds. Clouds are made up of water droplets of varying size. Tandaan ninyo, clouds are made up of droplets of water na iba-iba ang size. Smaller droplets scatter blue. Medium droplets scatter green and yellow, and larger droplets scatter red color. A combination of these colors results in white clouds. Now we know, di ba? Akala ko noon ng bata ako, iniisip ko itong clouds ay usok. Di ba, halimbawa nakita natin pag tayo nagluluto, tapos binuksan mo yung kaldero, makita mo talaga na may lumalabas na clouds, o mayroong lumalabas na white smoke, di ba? Or maybe halimbawa mga usok na nakikita natin na nakasindi halimbawa dun sa inyong basurahan. Akala ko noon, yun, yung mga usok na yun yung pumapataas, pupunta sa atmosphere and then nagiging clouds. Mali pala. Because clouds is made up of water droplets. Not this smoke or, di ba? Hindi yun. Let's continue. But wait, ma'am, question. Bakit minsan nakikita natin na nagiging dark colored yung ating clouds? Rain clouds appears dark because the water droplets become bigger and denser. Pag bumigat na at lumalaki na yung mga droplets of water, it absorb all the light, then scatter it. Hindi nila ini-scatter, ini-absorb na nila. And the result is dark or even black if all the colors are being absorbed. So ngayon, isa ding indication yon na malapit ng umulan or uulan na nga. So 'di ba, pag halimbawa nakita natin yung sky na may itim na, sinasabi talaga natin malapit ng umulan. So that's the science behind it. So pag bumigat na ito at hindi niya nakayanan, precipitation happens. Siyempre, umulan na. So, next time, we look up the sky and view the beautiful horizon and some other phenomena, you now know the science behind its beauty. Hindi na kayo malilito. So kung merong magtatanong sa inyo, meron na kayong explanations behind it. And I hope you can transfer it. You can share it with them. Okay? So now we are done with the scattering of light and dispersion. Let's move on to another subtopic which is all about interference and diffraction of light. So the beautiful spectrum of colors reflected on the soap bubbles, di pag limbawa, gumagawa tayo ng bubbles, nakikita natin talaga na mayroong rainbow, di ba? Nagpo-form talaga na mayroong doong kulay, rainbow. This is produced by the interference of light. That's the science behind it. It occurs when two waves meet while traveling on the same medium. It may be constructive interference producing bright fringes or destructive interference producing dark bands. Nakadepende naman sa medium kung paano natin siya ginawa at kung paano nagkaroon ng interference sa bubbles na yon, 'di ba? Kaya minsan nakakaaliw talaga gumawa ng soap bubbles, 'di ba? Kasi may makita yung mga different colors. It is because of the interference of light. In the case of soap bubbles, the incident rays of white light constructively interfere in different regions of the bubbles, producing the rainbow color appearance. Kaya nga, nagkakaroon at nakakakita tayo ng rainbow sa ginagawa nating mga soap bubbles. Now, how about iridescence? So iridescence is the term used to refer to the production of colors by interference in thin films. Other examples may include the beautiful band of colors you see in any shiny compact disc, 'di ba? Makita talaga natin sa CD, 'di ba, na mayroon rainbow na naka-form doon. Other than that, water with some oil. Minsan nakakakita talaga tayo ng rainbow din doon. The colorful feathers of birds, the fan-like feathers of peacock, 'di ba? May rainbow doon. May the beautiful changing colors on the scales of the snake and the colors on the oyster shell, 'di ba? Merong ding bands of rainbow. The interference of light clearly demonstrates the wave nature of light. Yun ang nagiging prueba that light acts as a wave. Now, next would be, do you experience or try nyo na ba ilapat yung inyong mga fingers sa rays of the sun? So as you look at the light through the slit between your fingers, you will observe the vertical white and dark bands, diba? Which is due to the bending of light as it passes through an opening or an obstacle. This is described as diffraction of light. So diffraction is dependent on the size of the obstacle. Nakadepende ang diffraction sa size ng obstacle. That is, it will take place if the size of the obstacle is comparable to the size of the wavelength of light, which is 400 nanometers to 700 nanometers. Now, if the size of the slit is near to its limits, only then we can observe the phenomenon of diffraction. So, nakadepende din naman to sa size ng ating obstacle. That is why the narrower the slit, the more pronounced the pattern becomes. So ano nga ba yung mga example ng diffraction na nakikita natin in our surroundings? Number one is the silver lining diffraction of light during sunset. Nakita natin na parang merong rays. Another one would be diffraction of light on trees during sunrise. Another one is the diffraction through door opening. So minsan, pag binubuksan natin yung ating door, o bubukas tayo ng ating pinto, at masyadong madilim dun sa loob, we can see the diffraction of the light. And, of course, the sun's corona. So yung nakapalibot na white light doon sa araw, it is because of the diffraction of light. So, my dear learners, now you know the science behind all of those beautiful phenomena we observe in our surroundings, diba? So, alam niyo na ngayon ang explanation behind it, okay? So, that's it. We are done with the wave property of an electron and also the properties of light. I bet you learned something from my lesson. And again, this is your teacher Dana saying, happy learning, share more, gain more, learn more. But please don't forget to subscribe, click the notification bar. If you have any queries or questions or clarification, don't hesitate to put your comments down and share more para mas maraming may matuto. I bet this is the end of my video lesson and I hope to see you again on my next vlog. Bye everyone!